In this video, I will show you how to use z-scores to find the percentage of data above, below, or between given values. Now later, you are going to need a z-score table like this one, so if you don't have one, go get one. Men's shirt sizes are determined by their neck sizes. Suppose that men's neck sizes are approximately normally distributed, meaning they make a bell curve like this, with a mean of 15.4 inches and a standard deviation of 0.6 inches. So we're going to start off with two graphs, and over here this is going to be inches, and this graph will be for z-scores. Now this line right down the middle is for the mean. So let's see. So in terms of inches, the neck sizes have a mean of 15.4. So we're going to put that here, 15.4, and we know it's inches. Now as far as z-score goes, the mean z-score is always 0, because any value, a z-score greater than 0 means that your neck size, in this case, is larger than average. If you have a neck size that's smaller than average, when we convert that to a z-score later, it should be negative. Now let's see. They want to know what percent of men have neck sizes smaller than 14.5 inches. Well, look, 14.5 is smaller than the mean. So I'm going to put that 14.5 over somewhere to the left. Okay, so 14.5 inches. Let's just say it's here. What percentage of men have neck sizes smaller than this? So if I'm talking smaller, then I'm going to shade the left side of this graph to show that these are the neck sizes I am interested in. So this is the percent that we're looking for, this percentage of the graph. Obviously something less than 50%. So if I do this math and I get something bigger than 50%, I know I did something wrong. Now we need to make the same picture over here in the z-score world, but you know what? I don't know what this z-score is yet. I do know that I want this part of the graph because we're doing the same thing. Okay, and these percentages should be the same. But we do need to find out what the z-score is. So we're going to use this formula. Z-score is always a specific value minus the mean divided by the standard deviation. So substituting that in, if I want to know what percentage of values are below 14.5, then that's, whoops, almost messed up. That's the specific value that I mentioned, so the 14.5 goes here. And then it's supposed to be minus the mean, so that'll be minus 15.4. Okay, again, it's the value minus the mean. This X bar stands for the mean. So the order is very important. And then divided by the standard deviation, which was 0.6. Okay, just put that in your calculator and see what the z-score is. Now I'm getting negative 1.5 for this z-score. Now I want to find the percentage of values that are less than 14.5. But I don't have a chart that's going to help me deal with inches. I only can deal in z-scores, so that's why I'm looking at this picture over here. I just found that the z-score that corresponds to this is negative 1.5. So I should put that on the picture. Now I don't know about inches, but z-scores, I have a whole chart of z-scores. And this chart tells me the percentage of data that's to the left of any z-score. So I want the percentage of data to the left of negative 1.5. I should be able to read this off the table. Oh wait, so first you need to write this down. We want the percentage of z-scores less than this, right? So I'm going to do less than negative 1.5. Okay, you got to use your notation. So now let's go find it. So we need to find negative 1.5 here on the left. And here it is right here. Negative 1.5. Now if there were any other decimals like negative 1.53, that would have put me over here. But negative 1.5 with no extra decimals means we're just going to stick here at 0. So I'm going to turn this into a percent, which would be 6.68%. So that is basically the answer to the question. This box right here is just a place where we will write our answer as a sentence, because this is a real world problem. We're not just cranking out equations and having meaningless numbers. This represents something and we need to explain that. So we could say something like this, if this word go would go away. That was horrible. 6.68% of men have neck sizes smaller than 14.5 inches. Alright, let's keep going and squeeze in this other part here. If Derek's z-score is 1.85, what is his neck size? So this problem is written backwards. We're given the z-score and we're supposed to work back to find the neck size. So we're still going to just use the z-score formula as soon as I can get out of this. Remember, the z-score formula is like this. The z-score is equal to a particular value minus the mean divided by the standard deviation. So we're given the z-score, so that means 1.85 equals. Now we're looking for a particular value, Derek's neck size. So I'll just call that x. Now the mean is still 15.4. and the standard deviation is still 0.6. So we just have to solve this for x. And we will do that by multiplying by 0.6 on both sides. So that gives you this. You know, these cancel each other out, so I'm just left with this. This times this gives you this. And of course, I'm going to add 15.4 to both sides. 15.4. And that's going to give me, looks like 16.51 inches. So that is Derek's neck size. In the United States, the average IQ is 100 with a standard deviation of 15. What percentage of the population would you expect to have an IQ higher than 85? Well, if the average is 100, that's going to go here. Average and mean are the same thing. So we're dealing with IQ scores here. So I'll label the chart. Now this chart over here is going to be, of course, z-scores. And the mean is always going to be 0 for those. Now, what do they want? Higher than 85. Well, 85 is below average, so I'm going to put that 85 over here on the left side. And I'm going to put a similar line right here, even though I don't know the z-score yet. Let's see, IQ higher than 85. So this time I'm going to be interested in the values to the right. So I'm going to shade over here to show that. Okay, and similarly I'm going to shade over here for the same reason. Alright, these percentages should be the same. But we need this z-score before we can go any further. So the z-score is going to be our specific value of 85 minus the mean of 100 divided by the standard deviation of 15. That turns out to be negative 1. So using our notation, we want to know the percentage of z-scores higher than 85. So that means the z-scores will also be to the right, greater than negative 1. Oh, by the way, the z-score here is negative 1. So we want the percentage of z-scores greater than negative 1, which in turn should be the same as this. Now be careful, because as you can tell by this diagram here in the corner, this chart only gives you the percentage to the left of any z-score, not to the right. So that's why I'm going to have to subtract from 100. So, I mean, looking at this graph, if the percentage of the data to the left was, let's say, 20%, the gray area is 20%, then what percentage of the data would be to the right? 80%. Okay, that's 100 minus 20. So anytime you're going to the right, you have to subtract from 100. Okay, so the z-score is negative 1. But let's right now go ahead and write down 100% minus whatever the chart tells us. So let's go find negative 1 and see what we've got. So here's negative 1 right here. And again, there are no extra decimals, so that means this is the value that we will use, the very first column. As a percent, this would be 15.87%. Okay, so 15.87%. And so we'll subtract that from 100. We get 84.13%. So that means this percentage right here, well actually, okay, we were just doing z-scores, so I should go in this order. So this percentage on the graph is what we just found. That is 84.13%. And the percentage on the other graph should be the same, also 84.13%. Now I just need a sentence. I need to write this up as a sentence. So this means that 84.13% of the population will have an IQ higher than 85. All right, now what percentage of the population would you expect to have an IQ between 90 and 120? Well, the mean is still 100 on the IQ side of this picture, and the mean z-score is still 0. Okay, so 90 and 120. 90 is less than the mean, so it'll be over here somewhere. 120 is above the mean, so it's going to be over here somewhere. And we want to know the percentage of people, the percentage of data between these two numbers. So that would be between here. Alright, so this is how you should shade in the picture. Now let's repeat that on the z-score side. Alright, and that reminds us that we need these z-scores, so let's find them. Okay, so let's see. Let's do the z-score on the left first. So I'm going to take my specific value of 90. I'm going to subtract the mean and divide by the standard deviation, which was 15. Okay, so let's see. That's going to give me a z-score of negative 0.67. Now let's find the z-score that goes with the 120. So I have negative 0.67 right here. Let's find this z-score. So let's see. So again, we'll do the specific value minus the mean divided by the standard deviation. And I'm just going to put that in my calculator. That is 1.33. By the way, this was negative 0.666 repeating. notice how I had to round this up to negative 0.67. Z-scores, you're always going to stop them at 2 decimal places, not 3 decimal places, not 1 decimal place. Z-scores will always be 2 decimal places in order to use the chart. This chart is set up for 2 decimal places. And round properly, or else you'll be in the wrong column of the chart. The 1.33 is the z-score that goes here. And I just realized I didn't shade this in yet, so of course over here we also are talking about between. But instead of talking about between IQ scores on this chart, it'll be between these z-scores. Okay, so in other words, we want to find the percentage of z-scores between these two. Now here's how you write between two z-scores. Negative 0.67 is less than z, which is less than 1.33. Alright, that's how you do a between. So what we will do is we will find the percentage to the left of both of these from the chart, and then we will just subtract the two. This is bothering me. Okay, we're going to have to subtract the bigger one minus the smaller one, so let's start with the 1.33 first. These are all negative, so that means I'm on the wrong side of the chart. So I'm going to come over here and look for that 1.33. So here's 1.3. The second 3 of 1.33 tells me which column I should be in. So 1.3, now this is 0, 1, 2, 3. So that is 90.82%. So I'm going to start there, 90.82% minus. Now I'm going to do the smaller one, negative 0.67. Negative, so I need to be back on this side. So here's negative 0.6, but it's negative 0.67. So this would be 0, 1, 2, 3, 4, 5, 6, 7. That's 25.14. %. So we will just subtract those and see what we get. And I'm getting 65.68%. Alright, so that means this shaded part of the graph is 65.68% of the data, which then means that this part of this graph is 65.68% of the IQ scores. So now I can write my sentence. 65.68% of the population will have an IQ between 90 and 120. Okay, a set of mathematics exam scores have a mean of 70 and a standard deviation of 8. A set of English exam scores have a mean of 74 and a standard deviation of 16. For which exam would a score of 78 be better? So we have two situations. We have the math exams and we have the English exams. So we can use z-scores to tell which one would be better. You know, when we say better, we mean which one is better compared to everybody else. Alright, sometimes this is called percentile. If you did better than 90% of everyone else, then you're at the 90th percentile. So we can use z-score, we can use z-score to find the percentile, and that will tell you how good of a score it is compared to the rest of the class. So for the math side, for z-score, of course, the formula is one specific value minus the mean divided by the standard deviation. Now the specific value is going to be 78 in both cases. Alright, so specific value of 78. Now for the math scores, the mean was 70 and the standard deviation was 8. Meanwhile, for the English scores, still we are looking at a specific value of 78, but let's see, the mean is 74 and the standard deviation is 16. So let's calculate both of these z-scores and see how they compare. Well, this comes out to be 1 and this comes out to be 0.25. So clearly 78 is better among the math scores. And you know, we could be real specific and talk about what z-score means when we write our sentence. We should use a different color though, probably. Okay, so look, we could write something like this. A score of 78 is a full standard deviation above the mean for the math scores. Alright, that's what a z-score of 1 means. It means that that particular value is one standard deviation above average, above the mean. For the English scores, 78 is only 0.25 standard deviations above the mean. It's only a quarter of a standard deviation above the mean. So yeah, you can see the z-score. So a score of 78 is a better math score. Alright, that's the answer. That's a full answer. But for extra credit, let's check out the percentile. Alright, we can use the z-score chart we looked at before to find out the percentile. So 78 is at what percentile for math and what percentile is that for English. So z-score of 1, if I go to the chart and find it, okay, here's a z-score of 1. That's 84.13. So that's the percentile. Let's see, can I use my pen, please? So just for discussion purposes, I'm just going to round that off. It's about the 84th percentile. So this math score of 78 is better than 84% of everyone else. So what about for English with the 0.25? Let's check that out. So let's see, 0.25. Here's 0.2, and this would be 0, 1, 2, 3, 4, 5. That's 59.87. That's almost 60%. So for this conversation, I'm just going to go ahead and round that and say that this is very close to the 60th percentile. Okay, so when you get your SAT scores and ACT scores, they will often, you'll see your raw score, whatever it is, but the main thing that you want to look at is what was your percentile? How did you compare to everybody else? And because that can be read in a similar way that you're used to looking at test scores. So 84 is much better than 60. Because this means you're only better than 60% of the people. You're still better than average, but for the math, you're much better than average. You're 84th percentile.